Hi, this is Randall Schwartz, host of Floss Weekly. This week, Aaron Newcomb joins me. We're going to be talking about Libmill, a way to make your C program do millions of things at once. Wow, is that even possible? You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CACHEFLY.com.
This is Floss Weekly with Randall Schwartz and Aaron Newcomb, episode 358, recorded October 13th, 2015, Libmill. This episode is brought to you by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code FLOSS in the billing section for a $10 credit. It's time for Floss Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at StoneEdge.com, bringing you each week the movers, the shakers, the big projects, the little projects, projects you may be using every day, totally unaware of it, projects you may want to go play with right after the show. Not if you're in the car. Wait till you get home. I'm giving this important safety tip every day now. So, joining me this week again is Aaron Newcomb. Aaron Newcomb, welcome to the show.
Hey, thanks for having me.
I should say welcome back. What the heck did I just say welcome for? It's not like you haven't been here before. You've been here as a guest, 3 times? And as a co-host, man, about 100 times now, right?
About 100 times, yeah.
But it's good. I love to have you on this show because you always have decent insight and can do things independent from my brain. And you also give me a chance to take breaks so I can come up with more questions, including whispering them in your ear. It works really well. And you're speaking to us again from your lair?
From my lair, yeah. You can see my wife's messy desk back there. And luckily, you can't see mine because it's way, way worse.
You position your camera specifically to make sure of that, right?
That's right. That's right. Exactly.
Good. Well, I am again speaking to you from Silicon Rainforest. It was cloudy last week and only got a tiny bit sunny towards the end, but today is clear. And for those of you who have watched previous shows that I've done from this bedroom, when it's clear, the sun will start hitting me somewhere from up over there, starting at about halfway through the show. So hopefully the lawnmower guy won't be back, or the leaf blower guy. So, but we may get a surprise visit from the leaf blower guy as well. So anyway, enough about us, enough about this week in geography. We have a really great show lined up today. We have Martin Sestrick, who I originally knew from the 0MQ project. He was one of the lead implementers, maybe the sole implementer. I'll have to ask him about that in a few minutes. On 0MQ. We actually had 0MQ on the show. Aaron, you may remember that. It was the time we did the show in the Brick House, the actual show. It was December 21st, 2011. We interviewed Peter Hinchins about 0MQ. Do you remember that one?
Oh, yeah. Well, I remember it because you were there.
Yeah.
And then,
unlike the way we normally...
Yeah, usually we don't get a chance to be in person together. And then you were there, and then I think the rest of the day you went around trying to sneak around behind everybody and everyone else's podcast, trying to get behind them and get your face in the camera a little bit.
I actually photobombed 4 other shows that day. I remember that. That was so fun. It was like, hey, look, I'm there. I kept tweeting, hey, I'm in that shot. So it was pretty fun. Yeah. So 0MQ is an amazing project. And one of the things I really liked about it was the notion of being able to have concurrency across small scales, across large scales, and being able to sort of migrate a task trivially from being side by side of the next process over to 2 different processes to being on the same, or being on a different machine nearby, or being scaled out to something really big. And so some of that is going to be reflected in today's project, which today's project is let me look, where's it? Libmill. So Martin has noticed that doing this kind of concurrency is really difficult. And one of the things that came along recently, we actually interviewed them in February of 2014, is the Go language. People are really getting excited about Go because it lets you write a program. And the language is pretty crappy. I shouldn't say that out loud. But no, I don't like the language very much. But one thing that it really has going for it is the idea that I can trivially write concurrent things. I can say, here's a task, here's another task, or here's a fleet of workers. And why might I want to do that? Well, suppose I have, all modern machines have multiple cores. If you write a single-threaded process, you can't take advantage of that. But man, threads are hard. I've tried many, many times, even using some added libraries to make them work. But I really like that Go just makes it work out of the box. And what Martin seems to have done is he's been able to essentially write a Go-like library in C. Now, if it's in C, it means you can drop it into anything, and you can use what you know from Go and then write your concurrent C programs. It even claims on the front page of their website that it can handle 20 million coroutines and 50 million context switches per second. That's impressive. So if Martin has seemingly provided the ability to do Go-like coroutines to allow separate thread execution and communication back and forth, trivially in C, this is quite an accomplishment. So I'm really excited to be bringing him on in a few minutes. Aaron, can you add anything to that part of the discussion?
No, not really.
Aaron, I'm so glad that you're a co-host for this show. I'll probably be giving you questions to ask through the middle of the show.
That'll be great.
I'm a serious programmer.
I'm already over my head in what you just said. I mean, because I'm a hobbyist programmer, so I understand a little bit about this, but I don't quite get the concurrency, the thing about concurrency and the coroutines and the million concepts. I will say that it's cool that this is being done for C. Because I think that, I mean, you can attest to this more than I can. As languages progress, all the new stuff seems to get written for the newer languages. So, Python and Go and those kinds of things seem to get the new features. And I kind of experienced a little bit of this when I went back to write something in C++ for Arduino the other day. And it was like, wait a second, I can't do this? Why isn't this working? This should just work like this. And it's like, oh, no. You can't do that. There's nothing to interpret what you just wrote in C++. It just doesn't work like that. And so I can appreciate this library at least coming back and trying to implement something like this for one of the older languages like C.
And one of the most interesting things I'm seeing, I'm definitely going to be asking Martin about this, is that he seems to have shoehorned this into standard C syntax. And I don't understand how he did that without having some sort of preprocessor. So I am definitely going to be asking about that probably a little later in the show. But speaking of later in the show, we're bringing Martin on in just a few minutes. But before that, I have a very important announcement. Because whether you're an experienced code warrior or just getting started, you need flexible, reliable, and affordable hosting. DigitalOcean provides developers with Droplets, which are virtual private servers that can be customized and deployed quickly to host websites, web apps, production applications, personal projects, virtual desktops, and almost anything else you can think of with full root access. I myself am a DigitalOcean customer, found out about them back in February when I heard they were running FreeBSD as one of their choices. I said yay, because it's so hard to find a VPS provider that's running FreeBSD out of the box. But I've been having a great experience with them since I became a customer back in February. And DigitalOcean is built for developers and is used by over 400,000 of them, including me. You can deploy and configure your Droplets via a streamlined control panel or a simple API. And again, you can choose your own OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD. And of course, that was my choice there. The servers can have up to 20 CPUs, 64 gigs of RAM, and 640 gigs of SSD hard drive space. You can deploy servers in regions all over the world with gigabit speeds and 99.99% uptime. It has an extremely active community with a large and detailed set of tutorials in all the ways you could use your Droplet. You want to deploy Docker, set up a mail server, they've got you covered. And it's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. I definitely attest to that. I can just bring up a new server instantly. And so DigitalOcean is incredibly affordable and straightforward pricing. The servers start at only $5 a month. There's also hourly pricing available, starting at less than a penny an hour. But we're going to make it so you can get started today and deploy an SSD cloud server for free. You can't beat free. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code FLOSS, just like the name of the show, for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do. That's DigitalOcean.com. And once you sign up, enter the code FLOSS in the billing section for a $10 credit. We appreciate DigitalOcean's support of Floss Weekly. Thank you very much, DigitalOcean. So let's go ahead and bring on our guest. Martin, welcome to the show.
Hello.
Hello. And where are you?
I'm in Switzerland, in Zurich.
Okay.
And it's evening here, raining. So
very cool. So
okay.
How well did I do in describing sort of the problem space and what your solution is for Libmill? How did I do?
Well, the thing is that I've got into the problem space with, as you mentioned, I'm the original creator of ZeroMQ and NanoMessage, and which both are messaging libraries. And it turned out that the hardest problem there was dealing with concurrency. Like what the things do is quite simple, but the implementation is really complex, and all because of threads. So I was thinking for years how to solve that, and like this is my answer for it. So I wonder whether people would use it for other stuff as well. It's completely new. The first version came out like a month ago, first stable version.
Okay, so how well did I characterize, though, why threads are important? And can you also talk about how difficult it is to use it with traditional interfaces?
Yeah, well, this is actually an interesting historical problem, I think, because if you think of how Unix looked like when it started, there were processes and pipes, and that worked perfectly well and scaled and so on. And suddenly, like in 90s or some, at the time, people started using threads for some reason, and then we've got into mess. And I personally have spent like years of my life just debugging race conditions and dealing with multi-threading. So when finally stuff like Erlang or Go appeared, it was kind of relief that we got back to the good old Unix system of processes communicating via pipes. But unfortunately, for C programmers, it's not that easy. We haven't had any good concurrency libraries for a long time. So this is the stuff I've tried to solve.
Okay, and one of the problems, you talk about race conditions. Why would you have race conditions? What's that mean?
Okay, so back to the basics. So the problem is that multi-threading uses shared state, which means that all the processors on the machine, or all the threads, depends, like are accessing the same memory. So what happens, they thread on each other's work. So what can happen that you do half a computation, and then the other thread just changes the data underneath you, and you're screwed, basically. So, and it's interesting why people have actually started using this, and the typical answer you get is performance, right? That doing stuff with multiple processes communicating via pipes is slow. And if you dig into it, what people typically speak about is TLB, the isolation of processes. You have to reload the tables that map virtual memory addresses to physical memory addresses. And that allegedly is slow, which I'm not that sure about, but certainly if you try to do like multiple processes communicating via pipe, it wouldn't be like 50 million context switches per second, right? So what we've achieved with Libmill is if you take the number 50 million per second, that means that one context switch per, I think it's 20 nanoseconds, right? So given our CPU clock rates now, that means that it's only few CPU instructions to switch from one context to another. And you definitely don't get that with multiple processes, right? So it's faster, but you don't have the problem with stepping on each other's data, because you communicate via channels, and you don't have any shared state to corrupt.
Now, one of the things that troubled people in the original threads was the idea of shared state, like you just mentioned, and you had to do a lot of like locking and unlocking, and you had to get that in just the right order, or you ended up with deadlocks. It's the old philosophers and forks problem, if some of you are familiar with that. How do things like Go and Erlang and now Libmill get around this idea of having to lock all of your data?
Okay, so basically you have two approaches. One of them is in functional languages, where you have no shared state by the definition. The only thing you are doing is computations, so there's no problem to solve. But for imperative languages like C, C++, Java, whatever, the problem you have to make some kind of abstraction to that is not exactly like mutexes, condition variables, or semaphores, but some kind of pipes between the individual threads or coroutines, right? So if you look at Go, what it has is channels. Like you send an integer on one side, it falls out on the other side. There's no need for the two processes to share any state, right? So that's what Libmill is doing. So
right.
we have completely copied the Go's syntax and semantics, right? So you have Go routines, you have channels, you have select statement, and so on.
Okay, and actually we have a question from the chat room already. We have a live chat room that goes on during the show from BFlub, I guess that's his name. Why C rather than C++? And are you targeting a set of systems that have concurrency but not C++?
Well, the thing is that what works in C works on C++, and if you look at a very low-level stuff where you need this kind of performance, it's often written in C. And the other problem with C++ is the dependency. So if you don't have a C++ runtime, there's no way to run any C++ code. But C runtime, CLib is available basically everywhere.
Now, given this thing's fairly recently been released, do you have any higher level language interfaces to it yet?
I think someone actually tried to do something with Swift, but I haven't checked it thoroughly. Like, it's a very new thing, so there's almost no ecosystem around it, right? As I said,
it sounds it sounds like a good call to action then to be able to have other people. Because the first thing I saw when I was looking at this is, oh my God, I want this to work with Perl today. So unfortunately, there's not a Perl live, but there are some sort of foreign function interface libraries for Perl. Would that be able to drop in and call these functions reasonably well?
Well, you would have to try. The thing is that the whole when we are dealing with coroutines, what we are fighting is operating system and compiler and the standard libraries, which can interact in very weird ways. So it really depends on how Perl is implemented and what kind of black magic is due, and whether that black magic interacts with the black magic inside Libmill.
Yeah, I know there's a little bit of somebody said that, the Perl syntax is parsed by, let's say, I think Yak, Lex, Smoke, and Mirrors. So there's definitely some problems with trying to get Perl maybe to work with this sort of thing. What kind of applications would need that kind of concurrency? I mean, obviously this works for some people, but what are they doing with this?
Well, I think it really is a solution for every application, right? So for many applications, you just use Go or whatever high-level language has green threads or coroutines or whatever. But on the lower level, you are often just left alone with C, and you have no resort. Like the thing is that there have been coroutine libraries even before, like libtask, but they were not very nice in terms of API, right? What really Libmill does better is providing a nice language constructs that look like reasonable. Like if you want to start a coroutine, you just say Go, and then you just call your function as you would if you was calling it like normally. So whereas in say libtask, you have to declare the function with one parameter that is a void pointer, and then create a structure, and then coroutine and pass it the pointer to the structure with arguments, which is not very nice.
Okay. And in the opening, I mentioned something about how I could relate to this by remembering what I knew about ZeroMQ. Is this library something that you can build, say, the next generation of ZeroMQ? Actually, you did that nanomessage. On top of, or would this sit side by side with other things that you would do to make that all possible?
It's former. Like the problem I was solving was the problem I had with internals of ZeroMQ and nanomessage. In both cases, it was supposed to be like extensible and open to people to participate on it, but it was so complex inside that very little development happened, right? If something like the 0MQ or nanomessage was built on top of this, much simple. Now, so I don't have enough time to actually do it.
Isn't that always the way? You have the brilliant idea, and then you don't have enough time to actually do all the stuff. So, yeah. I know we're probably, well, we had Peter Hitchens on a few years ago, 5 years ago, actually, talk about 0MQ. Can you talk about having developed 0MQ from the technical side? Because he was pretty high-level hand-waving. Can you tell us sort of how that all came about and what strategies you decided to use?
Yeah, okay. So from technical point of view, well, basically started with us working on AMQP, which was like corporate standard for messaging. And it turned out to be so complex that I finally got really fed up with it and decided to do something that would be easy to use. And that's what 0MQ is. And like as for the internals, I haven't probably realized the complexity of the threading model in advance, which resulted in very, dense and convoluted code, which is very hard to fix and maintain. So it also has a very big requirement set about it should work between processes, inside processes, between different machines, with different protocols, with different messaging patterns, and it should play well with threads and so on. So it's and should also work on Windows, which is a terrible task to do, like something that works both on Windows and Unix. So getting all those requirements done resulted in a very convoluted code. And I think something like Libmill would make it much easier to keep the complexity low.
So why? I'm gonna bring this up a level now, but why did you choose Libmill? I mean, why not libconcur or lib? I guess it wouldn't be libthread, but why Libmill?
Right. Okay. So it's a historical name because what happened? I've implemented 0MQ and a nanomessage, and then I just handed it over to other people, but it still like bugged me like how this could be solved properly. And I was thinking about it for a long time, and suddenly I had an idea how to do it. And okay, so this is so great idea that someone must have thought about it before. So I checked internet, and of course, like coroutines were invented like 20 years ago. So yeah, you should probably check your literature before inventing new stuff. But anyway, then I found out that there are already like coroutine libraries that you can use. I could have used that, but still the syntax was like ugly, and there was no obvious to fix it until what I've tried to do was to make a preprocessor for C that would take the line and regenerate it in row C so that it works as I expected. So basically what Björn Strostrup did for C++ in the beginning, like preprocessor to C, and it was like milling the code. So that's why I called it mill. But then I realized that it's too complex to do, and I switched to the different way of doing it, but the name stuck.
Yeah, it was too late at that point. You'd already kind of chosen it. So I love those stories, those origin stories, if you will, of names of projects and libraries and things, because sometimes you never know. Like when I'm installing something in Linux and I go to something, I'm like, what the heck? Where did they get that name? I mean, I understand the lib part; it's a library, but where did they get that? It doesn't make any sense. Was there anything that you gleaned from your work on other projects that you either fixed or you brought into this one to say, look, this didn't work quite right in 0MQ or whatever, and I'm going to do it differently here in Libmill?
Mm-hmm. Well, it's what I already spoke about. That this is really a tool for avoiding complexity in C. C is complex enough even when you don't use threads. And when you get threads into mix, it means that you are going to spend the rest of your life just fixing the race conditions. So this is the thing I try to fix. And actually, yeah, I think that maybe the whole advent of threads have been because of job security. So if you add threads to your application, you have another for the rest of the life. You'd never be laid off. So
yeah, no, that's totally right. I mean, I do a lot with in my day job around databases and database performance, and sometimes I think the same thing. Like, yeah, there's performance problems there, but there's always going to be a problem. Otherwise, we're never going to need DBAs. So there's always something going on. I noticed. I think that what license is Libmill released under?
Yeah, it's MIT. It's MIT. Yeah.
And why?
Speaking of,
why did you choose that?
Well, okay. So my opinion on the licenses for messaging software is that they should be as permissible as possible, because what they're doing with, a Libmill is something that's basically usable when you are dealing with network. Yeah, when you have asynchronous events coming in, coming out, and when you are dealing with networking, what you want is get a compliance from all the players, right? So if you invented a new protocol, you want it to be implemented in Windows as well as in BSDs and Linuxes and everywhere. And if you choose a PL, then you just no BSD, no Windows, just Linux, right?
I think we're getting a little bit of locking up there. So just wanted to make sure. Okay, you're still there. Okay, good. Okay, great. So who else is working on this? Is this something you're doing by yourself? Are you taking contributions from other folks?
Okay, so it's a very small project. So like I haven't measured like how many lines it has, but it's definitely like 400, 500. No, not completely sure. So it's very small, although a bit complex. And the other guys who will really help with that is Michael Goering and Nir Sofer. And interestingly, Jim Jagielski, who used to be, I think, president of Apache Foundation. And I really get like why he's interested in this, because if he worked on Apache web server, they had to solve the same problems as we had in Zero.
Yeah, I mean, you mentioned Apache. What about something like Nginx? I'm assuming the same thing there, right?
Yeah, well, probably. I haven't seen like how Nginx handles concurrency, so I don't really know. But yeah, it's web servers are the obvious target for this kind of stuff.
Yeah, absolutely. Are you still working on the other projects, ZeroMQ or any of those? Or are you completely dedicated to this now?
No, well, there's nothing much to be dedicated on it because it's basically finished, right? So what I've realized after being in the industry for 30 years or something is that what we should do is really finish stuff, right? So right now what you have is you create a project and it goes on for 20 years, 30 years, like whatever. And it's much better to do something small and keep it as is, like say make or grep. Those are great tools and haven't been changed like in decades, basically. So this is what I try to do with Libmill. Like it's finished for a month now. I don't intend to add anything to it. It's just going to be like this.
Is it really finished, or do you? I'm assuming you're going to keep working on it. Is it? I guess what I'm saying is could I pick this up and use it in a production application right now, or is it not quite there yet?
Well, nobody reported any bugs since the stable release was issued. So hard to say. You should try. If there are any bugs, I'll solve them. But there's definitely not going to be any like feature bloat or code bloat.
Right. And then, but I want to go back to what you were saying about projects being finished. I mean, because I think that certainly for me as a maker, I identify with that, right? Because when I'm building something, I like to get it to a state and say, okay, that's done. I'm going to move on to something else, because if I don't, I'll never move on. And then that has lots of problems because you don't get interested in other things, or you, I don't know, you kind of dry up a little bit. I think it's important to kind of move between things and have a beginning and an end. I totally get that. But then aren't there some things like languages that have to constantly evolve in order to stay current?
Well, I don't know. Take C, like it was standardized, like, well, not standardized, but developed in 1973. It was 40 years ago. And it's still basically the same thing, right? It changed a bit in 89 and 99, but like nobody complains, right?
Yeah. Yeah. So what other... Go ahead.
Yeah,
no, go ahead.
I think the way forward is to just do a new project if you want to change it. Like, why not?
Yeah.
If you want a new language,
yeah. So we mentioned. I'm just kind of curious. One more question, then I'll let Randall jump back in. But you mentioned web servers, web applications. Obviously, are our target for this. Application servers, I would think, would be a good target for this. What other areas do you think need this type of library in order to run more efficiently?
Well, I would say it's anything that gets external events, right? So if you just get input and then compute for 10 hours and then spit out the results, you don't really need it, right? But if you are dealing with incoming events from network or say from keyboard or wherever, then you get this concurrency problem that some computation is going on and suddenly like user jumps on something on keyboard or some packets arrive on a network and you have to synchronize everything. And in every such case, you need something in the same way, right? So like practically speaking, I would say it's mostly like implementations of network protocols, web servers, application servers. What else? Probably it would be interesting for people who are doing like very latency sensitive stuff where they can't afford high language than C, right? So as I said, like the context switch is 20 nanoseconds, right? So even if you take like high frequency trading, they're not speaking about nanoseconds, right? They are in the orders of microseconds. So they are like 500 times higher in what they do.
So I'm interested now because now it's starting to occur to me that this is the top dog event loop in my program. And I know that I have problems putting together multiple libraries that all want to be the top dog event loop. Can this work laterally with other event loops?
Well, depend on what do you mean by event loop. So if you mean like another coroutine library, no, that would probably just break each other, right? Because what coroutines are doing is really breaking the C stack. It's quite hard to get it even work with like normal compiler like GCC. And like if there are two of them, they would certainly like just destroy each another. But if on the other hand your event loop is something like glib or something like that, there should be no problem. There should be no interactions.
Okay. Then or was I getting at this? One of the things that was impressive to me from when I was dealing with with SQLite with Richard Hipp was that there were some projects that were actually just dropping the source code for SQLite and shipping with it because they didn't want to have to worry about a dependency of installing an SQLite from a library or something. Is this similar to how you envision Libmill, or do you think this will end up in distros as part of the library's packages?
Well, actually, I've already seen that someone done a package for Arch Linux already, although it's like a project that's just a month old. But really, the thing is, it has no dependencies whatsoever, and you can link it both statically and dynamically. Like, and especially with static linking, you have no dependency, right? It just becomes part of your executable binary. And it's very small, so it won't add much bloat to the executable.
And actually, somebody from the chat room, when I was trying to think of other examples of event loops, is would it work for things like it's secondary? I wish people would have pronounceable names in the chat room. Could it be used for user interface libraries? Like, how would it play with GTK? That's another event loop that wants to own the UI.
Yeah.
Is there any way you could use Libmill together with something like GTK?
I must say I have no idea. Like if GTK runs in a single thread, then probably yes. If it tries to do multi-threading stuff, that may be a problem.
Okay, so this is kind of again, it's like it's a way to turn your single monolithic C application into something that looks a little bit more like Go, but it really doesn't play well with others if they already have their idea of threading somehow.
Yeah, right. And what I think the thing you already mentioned about Go there, people have various like impressions of Go, like some love it, some hate it. But even the people who hate it, what they say every time is like the Go is complete disaster. But there's one good thing, and that's the concurrency thing. So this is kind of like ripping off the concurrency thing, putting it to C without any other stuff.
And in fact, to that end, I noticed that the syntax on the front page of libmill.org, you really tried to mimic the Go syntax. And you see here in Go, it's like Go, foo, arg1, arg2, arg3. And in C, it's Go, foo, arg1, arg2, arg3, almost exactly this. Now, you're not pre-processing this C, are you? How are you achieving this?
Yeah, that's actually pretty interesting stuff, what's happening inside. It's complete black magic, and it's definitely something you shouldn't do at home, but what it does is that in C you have this thing that's called like dynamically sized arrays on the stack, which means that on the stack you can declare array of a variable size. So you say it's 100 bytes long or 1,000 bytes long, and what it really does, it moves your stack pointer by 100 bytes or 1,000 bytes. And what you can do then is that you allocate a new stack, and you create a dynamic array so big that it actually overflows by the end of the memory and gets back and lands up exactly at the place where the new stack is allocated, right? So it's really a dark magic, but what you end up with is that your stack pointer is at precisely the point you want it to, and if you call a function at that point, the arguments of the function are stored in your new stack, and even if the old coroutine finishes or anything, it's still in memory, right?
Mm-hmm.
Yeah, I know it's hard to understand, but yeah, that's what it does.
I just like, as I stare at it, it's like, okay, the Go routine is calling the other function, and somehow when that function comes back, it's still running. That's just bizarre to me. I don't totally understand. I'm not much of a C programmer, and what you said, actually, Aaron, I now know what the rest of the show sounds like to you, because it's like, okay, that just went over my head, so that's fine. But I do want to ask sorry, yeah. Aaron.
Yeah, I just wanted to say that it's really not intuitive, like what it does, but it works. So you as a user are really shielded from the black magic.
Okay, that's cool. And the other thing that I saw sort of interesting was this choose statement that looks a lot like the select statement from Go. And choose isn't a keyword. I bet you're using a pound define there, but I have no idea what you're doing after that to make those labels actually work. Can you tell me the magic in that, and I'll let that go over my head too?
Yeah. Well, several people already looked at those macros and like went away with saying that their head hurts. Yeah. So what's happening there is that it's as the macros are expanded, it's actually building a linked list of clauses on the stack. So it declares each step declares a variable which says like, okay, I'm waiting for input. Here's the pointer to the channel I'm waiting for, and it put it on stack. And the next one creates a new clause on the stack and links it to the previous one. So what you end up with is a linked list, but it's completely stored at the stack, so you don't have any memory allocations or anything. And when you arrive at the end of the statement, then the last macro expands into a function call, which gets the pointer to that linked list, and actually that does the waiting for the channels.
Okay, so it's magic. I stopped listening after that. Sorry, I'm sorry. It's like I do understand. I understood most of what you said, but I tell you, this is just. I'm glad that you're brilliant enough to come up with this. Is it going to be fairly straightforward for someone to use if they don't know Go? I know you chose like a Go-like syntax, but is it going to be? I mean, is your documentation standalone enough, or do they need to come from an area of already knowing how to deal with threads and channels and things like that?
Well, it's certainly good to know Go before, or some similar language with channels. I don't know whether there's any other, but it's not really hard. Like even if you want to learn Go, it takes like 2 hours or something. Their intro is very short, and also I've written a tutorial for Libmill, which builds a multi-threaded server in like, and the whole code is like 50 lines of code or something. So it's
I scanned through that actually, so I understand most of it because of that. So that's really kind of cool. How portable is this? I mean, you must be talking to some underlying interfaces. You list like 7 or 8 OSs that this seems to be already ported to. Are you talking to a standardized interface in all of those, or do you have to have some of the sort of glue logic different per operating system just to make it work?
Well, I haven't expected it to be portable, because if you look at coroutine implementations, some pieces of assembly that actually do the context switching, but in the end, it turned out that if you use this weird trick with dynamically sized arrays to create the new stacks, it works pretty well with basically every operating system we've tried it so far. It's really undefined behavior in C, and you shouldn't do it at home, but it seems to work. What was really a problem was making it work with the compilers, because really the most and on the compiler, like how to prevent optimizations at certain places where they messed up the stack, and also with CLib, how to turn off like sanity checks there, so that it doesn't complain that the strange things are happening.
Yeah, and you mentioned assembly just a moment ago. I presume then that this is x86 only then?
No, actually, there were people who tried ARM, and it works. Like there's not a piece of assembly inside, right? It's using using this strange thing to shift the, but it's like a regular C, right? So yeah.
Okay. Well, that actually is one. Sorry, go ahead.
Yeah, so I wouldn't have expected that is doable myself like a year ago, but apparently it is.
Well, now since this is a done project, as you keep saying, and you have like 0 bugs, there's not even like a bug tracker for it anymore. I mean, do you envision adding any more to the API at all?
No. Like if anyone wants to add anything, like just make another library.
Libmill 2 or
yeah. And there is a bug tracker in GitHub. So if there's a bug, just fill it in, solve it. But really the code base is very compact. It's 500 lines of code. Hopefully, like there won't be much bugs.
Well, if you had a call to action, if you had some requests to make of our wonderful audience for doing more things with Libmill, what would you be looking for? Are you looking for people to do translations of your docs, for example?
Well, I wouldn't be opposed to that, but what I mean is, if you want to do something interesting with it, just build on top of it, right? So you can implement different interesting protocols using it and expose it like your own library. Like there's no much point messing with the internals of it. They don't do much. They just do channels, the coroutines.
Okay, and actually we have a question from the chat room again. Secondary, which I can't pronounce your name. I'm sorry, Seconder. Anyway, is it dependent on a particular libc, like glibc 2.5 or something?
Well, I have just worked with a single version of libc, but other people have compiled it with different versions and they reported it works. So obviously it works. The trick that we had to do to make it work is to switch off some sanity checking in libc, which can be done like from inside the library. So that should be transparent for you as well.
Yeah, we actually had some questions in the chat. I'm just to acknowledge the people that asked that about comparing ZeroMQ and NanoMessage and a few other things. But, you know, I think we're going to get your successor, your heir apparent for NanoMessage on a future show. So I'll save those questions for then. Unless you want to address the overall thing, which is why did you leave ZeroMQ and not fork it essentially, but start over from scratch and make NanoMessage?
Well, it was, we were not like on complete agreement on how the projects should continue. And it was also an opportunity to rewrite it, whichever engineer like really likes to start from scratch. So that's it. And for NanoMessage, I had to hand it over because, as I said, I have a kid now. So
yeah, that does take some time. I've heard that from my friends who have kids. I do not yet have kids, and at 53, I'm probably not going to have kids. I think it's a little too late to start, although people will argue with me about that, but that's okay. Also, the other thing that I remember reading about when you went from ZeroMQ to NanoMessage is that you started over and did it in C instead of C++. Can you explain a little bit about why you did that?
Well, the thing is that C++ is a kind of language of choice because there are so many programmers who use it, right? So if you are starting a new project, it's like obvious thing to do. But then if the features of C++ really, so everyone's going to add new stuff. And then when C++ was basically stable, it was like, do we really want exceptions in the library? Well, probably not. Like it's a high performance thing, and a high reliability thing. So you don't want exceptions there. And do we really want, I don't know, like people messing with multiple inheritance there? Well, probably not. And with C, it's very easy to keep it like this because it's C, right? You don't have much options there. So that's the main reason for using C.
And we're almost out of time. Is there anything we haven't covered that you want to make sure our audience is aware of about Libmill?
Okay, let me see. I have written some points down, but yeah. I think that we've basically covered everything. Okay, I should make a statement about that I don't speak on behalf of my employer and all the opinions expressed are my own. So sorry for the legalese. Yeah.
Not a problem. Not a problem. Great. And I have to ask two final questions or else I actually do get email or chat room people yell at me. What's your favorite scripting language?
Scripting language? Well, I actually like Ruby myself. I don't really like where it goes, but I like the syntax.
Actually, Ruby doesn't have bad syntax. I'll give you that one. Ruby is the sort of awkward stepchild of Perl and Smalltalk, my two other favorite languages. So I'm surprised I never really adopted Ruby, but I think it's because I'm waiting for Perl 6, and Perl 6 has everything that Ruby has in it, and it's right around the corner.
Yeah, so. It's out. Yeah, it's out now.
Yeah, well, actually, it's been out. There's a release every single day if you're building the downloads. I mean, so I've been doing that for almost 2 years and playing with a little bit each time. But they're going to have the official release coming up this Christmas. Actually, this Christmas. You know, we keep joking about Christmas, but this time it's actually really happening. Perl 6 version 1.0 is coming out. Yes, I love that. Anyway,
are we going to do a show about that?
We'll have to, Aaron. I'm pretty sure we're going to have to. Yeah, we'll get Mr. Wall finally on. That would be really cool. I got one more. Great. Yeah, that'd be great. That'd be great because he hasn't been on the show yet. And also one more question, Martin, before I let you go. Your favorite text editor?
Text editor. Well, I actually like Wysiwyg, which is strange for a programmer, but for some reason I like stuff manually, so I just use gedit mostly.
Gedit, okay, that's a different one.
I like gedit. No, I'm right there with him. I like gedit. Yeah, it's good. It's not bad. I mean, you can always pop out to gedit and get a little visual, a little easier to copy and paste things. So it's nice.
Mm-hmm.
Very cool. Very cool. Well, thank you for giving your time to us, Martin, today. And this is, as I said in the beginning of the show, this is kind of a geeky show, or maybe 2/3 of our audience has already hit stop or fast forward to the next podcast they're listening to. But I think there's probably a few that have been inspired by this and are going to go check it out after the show is over. So thank you for coming on the show and talking to us about Libmill.
Yeah, thanks very much for giving time on our show.
Very good. Very good. That was Martin Sustrick talking to us about Libmill. I'm afraid to ask this, but Aaron, what did you think?
Well, like we said at the beginning, I think this is something that's really needed. I think that there's some things that even I can glean out of this. Number one, the fact that he said he's kept the code sort of short and sweet, I'll say. He's kept things clean, so there's fewer bugs. I think this is the first the first show that I've ever been on where someone says, look, it just got released and it's done. Like 1.0 is out and now I'm done. And I don't expect any bugs. Like what planet is this? This stuff never happens. So, but I think there's something to be for programmers, especially programmers that are just starting out. I think there's really something to be said for that. And so certainly I'm going to take that to heart and see, okay, can I simplify my code? Which I think is a question you should always be asking. And I mean, how do I do this in a simple way so that I'll avoid problems later on? And then, of course, there's the other things we talked about, the whole importance of this in terms of threading and having concurrent processes running and things like that. I mean, that's all important. But even above that, even if you're not a programmer, I think there's things you can learn from the way Martin develops his code.
Yeah, and even the chat room picked up on this, and it's sort of the same as. I know you remember a few weeks ago. You were on the Suckless show, right?
No, I missed that one, unfortunately.
Okay. Oh, that was Dan. Okay, but Suckless or whatever they pronounce that. It was also like that. It was like, keep it small, keep it simple. If you can do it in 50 lines of code, don't take 100 lines of code to do it. If you can use 5 switches to control things instead of 10, do that. And so their code was very small and very easy to maintain and very easy to understand. And it sounds like he's been able to do the same thing with Libmill. So I appreciate that sort of thing. And back to the issue of threads. I remember when Perl first added threads because it was all the rave. This is like almost 20 years ago, I think. And the problem was that it was a shared everything approach. And so much disaster came from that because you had to remember to lock the variables that might be being changed by 2 things underneath. Which is a real pain. And then they went to the shared nothing approach. So basically you have to do like it's being done in Libmill, where you send things from one thread to another. And that all of a sudden made threads much more tolerable. Still sucked a lot, but it made it suck less. Not to be a reference to the other app, or the other project, but I remember that transition, and I remember saying, well, that makes sense because, originally you did everything in Unix using processes and pipes and network connections, and that worked really well because a process was its own address space and its own concurrency scheduling. The kernel was the scheduler of the threads in a Unix system. And in fact, I used to tell people the way you spell thread in Unix is F-O-R-K, because that's the way it was done best. And it sounds like Martin's been able to bring that down to the level of concurrency, but within a single app and within a single process, being able to take advantage of multiple cores, to being able to take advantage of, children workers that can process at their own independent rate, things like that. So I'm pretty happy about this. Anything else before we move on?
Nope.
Okay.
I'm trying to keep it simple, Randall. I'm trying to keep it short, simple, no bugs in that answer. I said no, and that's it.
Well, we still got 4 minutes left of the show, so I want to make sure we come up on our hour in a proper way. Aaron, you're going to like the next 2 guests that we're actually bringing on, and I don't want to make you be the co-host 3 times in a row, but you may be slightly tempted. So we had the Crowd Supply show on a few weeks ago. We have actually on the short list, including one already scheduled, a couple of the projects that were funded using Crowd Supply. Next week, in fact, we have Tim Ansel, who is the Numato Opsis, and that's recording, routing, routing and manipulating HDMI and display channels. And that was one of the projects that was successfully funded and is now available for purchase through Crowd Supply. He's going to talk to us next week. He's actually in Sydney, so he's going to be up at 2 a.m. his time to be on this show. But he says, I'm always up at 2 a.m. anyway. No big deal. So that's really great. Also, another one is on the very short list, but they haven't actually fully confirmed. Another project that also came from Crowd Supply is Snickerdoodle, which is a Raspberry Pi and Wi-Fi for robots.
Yes.
So,
Yes.
Have you seen that before? Have you played with that at
Yes,
all?
I have. Yeah, absolutely. Yeah, that's really cool. It's I don't know if, well, we probably don't have a picture of it, but it provides a lot of inputs to GPIO pins and things to use, and I believe it's also configurable. You can change the pins, what the pins do around, which is not something you can do with Raspberry Pi and Arduino as easily without getting into the code,
Awesome.
kind of getting in deep into the code. So you can do things, kind of dynamically. And I think it's built on operating system or an architecture, Dynex or something like that. So yeah, I know about that one. It's pretty cool.
Very cool. Well, maybe we'll have you back as at least as a co-host for one of those. But that's probably going to be like 2 weeks from now. That's our one open slot for about 2 or 3 months. So I'm hoping that they come on and fill that slot. Also, speaking of upcoming guests, we got OPN Sense, which is a FreeBSD-based firewall fork of PF Sense. We had PF Sense on the show a few years ago, and we're going to bring on a fork of them and talk about why they forked. And then Dart, the programming language, one of my favorite new languages. Casper Lund and some co-guest to be named in the future. But we'll be talking about everything that's happening in Dart, including perhaps an announcement for Dart 2.0, which would be really cool. They've been slowly adding features to it over the last year or so, and so it's been really fun watching all that and its adoption and the changes in strategy. Like it used to be that they were trying to get the Dart VM in every single browser, but they gave up on that, and that's great because now it means they have to efficiently compile Dart into JavaScript for all architectures, which means the rising tide lifts all boats finally, which is really cool. We also have Caddy on the list. That's a high-performance web server written in Go. Speaking of Go, again, this thing's really taken off. A lot of people are playing with it. I've been sending out emails rapidly, trying to score some more people for the last few weeks we have left in the year that are not scheduled yet. I will announce those on the Google Plus for Floss Weekly, which is Floss Weekly. And that also automatically tweets over to Floss Weekly at Floss Weekly on Twitter. If you want to see my actions there and see who I actually have on the short list, you go to twit.tv/floss, which is the homepage for this show. And from there is linked, see our upcoming guests. And if you go to that link, you go to a big Google spreadsheet that I have set up, which shows my progress in trying to get people on the show. If you have a project that is not on that list, please email the project leader or the community coordinator and have them email me, merlin@stonehenge.com. Don't just tell me about the projects. That goes way down in the middle of my list. I never get to it. I have to kind of work with people who are already primed and are just looking for a slot. I can't spend all the time doing the sales work for this show. I'm already putting in about 5 hours a week for this show, and I can't really put much more time into it. But I love doing the show. I'll keep doing it as long as Leo lets me do it. Okay, so you can also follow me on Google Plus as Randall L. Schwartz, and you can also follow me. We send tweets over to Merlin, MERLYN. I have nothing really to announce about public places I'm going to be other than Scale next year. I'm just kind of taking it on the wind down at the end of the year and doing the holiday thing. That's kind of always the way this works out. Aaron, you want to plug something today?
Sure, why not? You can actually one of the things you can do. Well, first of all, let me apologize for the intrusion of my phone. Here, it's kind of loud. So if you were listening to you probably heard my phone ring a couple times, unless the editors are so paying attention so much that they're able to take that out. But it's kind of loud, but it's also kind of cool, and it's actually really fun to use because we're so used to our cell phones. It's fun to use an old-fashioned phone like that, so it's kind of cool. But other than that, you can find kind of follow me what I do on Google Plus. You can see the link down there in the lower third. That's who I am on Google Plus. That's where I share just about everything that I do. I try to post something on there. The other thing that I'm involved in is Benicia Makerspace. So I'm the president of Benicia Makerspace here in my hometown. And if you go to beniciamakerspace.org, you can kind of follow what's going on. I'm trying to do blogs now. What's new in September, what's new in October. You can kind of see what equipment we're getting, what's going on. And of course, I do shows on, see now my other phone's ringing. What is going on today?
You're a popular guy, Aaron.
Oh, man, tell me about it. This is awful. I also do shows, other shows on the Twit Network, like This Week in Google. And in fact, if you go to BeniciaMakerspace.org, you can see the end of This Week in Google, where I showed off a couple projects we're working on at the Makerspace. Our new doorbell, which uses this big paging speaker to ring the doorbell. It's kind of crazy. And the Onion Omega, which is kind of like a little Raspberry Pi type of a board with built-in Wi-Fi. It's pretty cool. I just got that off of Kickstarter. So if you missed my appearance on This Week in Google, go back and check it out. And you can see some of those things that I like to work on.
Awesome, awesome. And I think I've made it all the way through today without having the sun directly in my face. Although if you're watching the video, if I go back just a little, no, where'd it go? Okay, now the sun's nowhere near me, but I was trying to avoid it earlier. I guess I went behind a tree or something like that. And there were no lawnmower guys. I can't believe this. I did a show at home, and there were no lawnmower guys at all. I'm kind of disappointed in that. But Aaron, thank you for coming on at the last minute again and doing this show despite your reservations about having nothing to say since you're not that much of a programmer. I think you did really well on your list of questions.
Oh, well, thank you very much. I'm glad to add my own interruptions so that, you know, the audience wouldn't be missing them. We wouldn't want to have an interruption-less show. That wouldn't do.
Awesome, awesome. And I'm sure you're going to be tempted to, you're probably going to have to duke it out with Guillermo about who's going to come on these two upcoming shows. But I'm sure we'll have more stuff like that coming on as well. So again, but thank you again. Thank you again for being the co-host.
Sure, no problem.
And we'll see you all again next week. Let's see if I can do that right. Take two. We'll see you all again next week on FLOSS Weekly.